And the one part we didn't really go over was where was it here? It was classes. Way at the bottom here. What were classes? We were talking about objects and object-oriented programming, but with ES6, it gives us syntax to do these kind of things in JavaScript. It's not truly an object-oriented language, but it's going to pretend, if you have context to what classes are, strongly typed languages, it gives you that feeling. So classes are like this. Remember their blueprints. So you have a car. Car has a class. Car class has a color. Every other derived object is a car. They all have different attributes. They all have different colors. It could be a user class with name, these properties, name, status, some functionality that is encapsulated inside of that user object that can float around and then be reused for every different instance. So you have a user 1 or 2, doesn't matter. You know, if it's 10, 100, 1,000, you have a blueprint that you can quickly use, right? Like a block on the chain, right? And your block has functionality built in. Your block would be a class. The blockchain would be a class, and it has functionality there in it. So for ES6, they had this new declaration called class declaration. You can do the same thing where you want to do a class declaration, which you'll see quite a bit in React. You can also do that expression where you can assign it a variable if you wanted to. Main thing to note here is they have something called a constructor, which builds the properties for you. So I'll show you what that means in a minute. And then we'll get deeper into this with the React. But the point is if you wanted to extend your class to copy that blueprint, you had an animal that was a base class, and you wanted to say, hey, there's a lot of great information in there. I don't want to copy that base class again. I would like to extend it. So maybe you have a car and you want to extend the base car to be an electric car. You could, instead of creating a brand new base class for electric cars, which gets confusing, you have 2 objects then, 2 base classes, you could say, okay, here's a template from a car. I want to extend it to be an electric car. It still has all the properties of the parent. Maybe I'm just adding, like, you know, some specific properties for the electric car. And there's some other things as well, but that's a good idea. We're going to circle around to this when we're going to circle around to this. Oh, I'm looking at the transcript. We're going to circle around to this when we are doing React. Everything will be a class. So anyhow, coding part. So I think when we did this original, let me close my terminal window here. Let me close out Control B and take a better look at this. If you recall, we created, and I kind of messed this up a little bit with some examples built in there. Why is this example in there? Let's take all this out here because that was not related to it. So we had a functions. We had a bunch of functions in here, methods, functions, JavaScript functions. You can see over time, if you really start to look at this, you can see that it's a bit incoherent. You know, if you didn't know what this was, you would start to see that the more functions I add, the longer my file gets. It's not too long. Then you need to kind of inspect all the functions and say, okay, well, initialize what? Okay, well, that initializing the block, I guess, the blockchain. Creating block, add block, get last block, calculate hash. Like, they make sense to me. I know how to run them and call them. If I were to run this guy, node 1.0, it creates a simple blockchain with a hash and previous hash and an amount. Not much to think about, but there's a better way. There's a better way to organize all of this. So that's where classes come in. Prior to ES6, they had different mechanisms in JavaScript to do this kind of thing. They had closures. They had modules, different ways to try to do it, but those are a little bit harder to pick up. I think if you're coming from object-oriented programming languages, you understand what a class is. So ES6 tries to give you that syntax. However, just note, it's not a true class. It's not a real class. It's just they call it syntactic sugar, to make you feel like you're coding those languages. And then when the Babel compiler, the compiler will take it, whether it be in the browser or Node.js, it'll convert it down to vanilla JavaScript anyways, but really complicated, complex, minimized JavaScript that only the compiler understands. But anyhow, I digress. That's what it does. So I already have a solution already. Let's see if I can, we can do this, right? So we'll just do 2.0 blockchain, just like this. And we'll try to start, and I'll try to explain as I go. So a bunch of methods here, a bunch of functionality. They just kind of sit in the file. If we know how to use all of them, then it makes sense to the developer, but there is a better way to organize them. So for instance, we know out of the gate that we need an object for a block. So we would do some we would use some syntax to create an object, or start to create an object that is a block. And at the very least, we also know that we need an object that will be a blockchain, right? Blockchain. So we're creating this template. And then we would probably decide, based on some of our examples, where would some of these methods go? So I know for a block, we had something down here now, calculate hash. So that was on the block itself. So we would probably have a function or method inside of this called calculate can I spell? Calculate hash. And for right now, it's just going to be empty because we're just trying to build an interface or a signature. When you actually do object-oriented programming in other languages, they have something called interface. And interface is like a contract for the class that can be used, right? So we're not creating that. But if you were to create a contract, you would kind of create it in this way. You'd say, okay, here are my objects. They have this functionality. I don't need to implement what they are. But if you were to look at any one of these classes, you'd see a signature that you could read and then use. You could do all sorts of crazy stuff with that. All right. So if I had every class will have something, whether or not you implement it or not. There's always going to be a constructor function. So what the constructor function is, whether it's defined or not, it'll always be there. And this is responsible for constructing your object. So if you don't define it, in behind the scenes, it'll always run, and it'll take care of like the initial construction of that class. A great thing with it is you can also pass in parameters, and this is where you would do all the setup. So if you wanted to set up a bunch of things on your block class, then you could, because I think we said, what does a block look like? And I think a block has a hash, previous hash, an amount. And we had to create a little function here that did the setup every time. And if you notice down here, we always had to call it. So it's like you create a current block, and then you had to go and you had to do this extra work. So every time that we create a new block, 3, 4, 5, 6, we have to do all of this kind of invocation and all this extra logic that makes it a little bit, it makes it hard to construct. So then, all right, so we could use this constructor to set up the block. And I think we had an index, a timestamp, some kind of data, I think, and a previous hash. So we may not know the previous hash, but we'll just default it to an empty string. And from then on, we can use the keyword this. If you remember, this keyword will bind it internally to the class itself, the object, so that as the object floats around the blockchain, the block knows about its own hash, I know it doesn't have an index, but we're doing a simple kind of setup here. So internally, it doesn't have to be the same name, but we could just do this setup, right? Index is equal to the index passing in. The timestamp is equal to the timestamp coming in. The data is equal to whatever. Now, they don't have to be the same. I could say this is a ph if I wanted to, right? I could say just ph equals previous hash. Like, it doesn't really matter. However, it should probably make sense to us, right? What that is. In case we want to expose this data back to the caller, we need to know what what it is. So now what's going to happen is if we ever create an instance of this block and pass it in some interesting things, it's going to know, it's going to do the setup for us so that we only need to call it inline. We don't need to keep doing this setup all the time, you know, every single time. So we've kind of eliminated some complexity there. All right, so if we look at the blockchain itself, it has a constructor, but maybe the constructor is not going to take any parameters. It's just going to do some setup. This is where we would initialize some things. So if we wanted to set up what our chain is going to be, so this would be initialization. And we said we had a blockchain somewhere in here, right? Somewhere in here we had a chain. And I think we had to define the chain way outside in a global. So it sat in the global scope of the whole application, this blockchain, which is probably not that good being in the global space because somebody could overwrite it, especially if we're using vanilla JavaScript. If we didn't want anybody to overwrite the blockchain, we'd have to give it that constant variable from ES6 and then lock it down. However, the fact that it's out in the global space is probably not a good thing. It should be internal to our blockchain object, because the blockchain will be a big object that will have a snapshot of everything in memory. So we have like a internal property called chain, and for now we will initialize it in the same way for now. If you notice the setup before, the initialization was out here, and we had to create a Genesis block and add it in one step. And if we didn't call this here, then we would have a situation where that first block would not be initialized. So we could easily miss that. If we put it inside of the class, whenever this is created, it'll always create that Genesis block for us. And I'm trying to remember. Okay, so let's create that. That's a good method that this chain should have, is a create Genesis block. And what this guy will do it will go and call this class, and it'll create a new block. So we have, right when we start this blockchain, we'll have a Genesis block created, and we'll be able to add it right to the chain as the first element, eliminating a lot of these calls here, right? We don't need to do this setup. So this guy should, what should this guy do? It should return a new block, I believe, a new block, and that will be the block class. We're creating an instance. It'll have a 0 index. It'll have, I don't know, some date, whatever, 2022, and this guy will be the Genesis block. And we're going to have a 0 amount, I believe, or a 0 hash. Remember, if I misstep here, I'll always look at the finished example. And then if we have this Genesis block, so now when somebody invocates our blockchain, we will initialize the chain. And why not just right away add that Genesis block? So right away, it's going to be an array that just has a block in it, which is great. So let's actually try to create a blockchain here. Let's see here. So if I way down here, I wanted to kickstart this guy, and I'm just going to say, okay, my chain, or whatever we'll call it, we'll say the chain is equal to a new blockchain. And what we're going to do is just quickly console log out what that chain looks like. And if I wanted to run this program, I got to use the node shell. So I go to terminal window and run this guy, say node 2.0, tab to bring it in, and right away I have a chain, which is an array, a data structure that has one block in it, and then there's the information about the block, and that's the Genesis block. So if you noticed, it's a lot easier just to create my invocation of the chain to kick everything off compared to this kind of call here, right? I have to initialize. Remember that if I have to call this every time, otherwise it won't initialize properly, which is not good. It should be inside of the blockchain. This is the initialization part should be part of the object internally, and that's what it does. So as soon as we create it, it goes off and it kickstart that whole construction of the chain, which is valid up to this point because it's the first object. So then what else do we need on that? So if we were looking at some of these other methods here back from here, we probably need to be able to add a block, get the last block, and get, I don't even think we need to get blockchain itself because we don't need that anymore because we have it. But adding a block and getting the last block certainly would be probably methods that we could probably use, right? So we could say add block. And if you notice, because this is inside of a class, you notice how I'm creating my, now they're functions, but they're methods. I don't have to necessarily define them like, I don't have to necessarily give them a var keyword. I could, I guess, but could I? It's probably best because they're methods. Yeah, that they should be defined this way. That's part of the syntax. And if you're coding in C# and Java, this would be very familiar to you, that they are methods now. They are still functions. They operate the same way. You just define them a little bit differently because it's in the confines of this syntax called a class. Again, if you don't have browsers that understand this, it won't work properly. So add a block, which is add a new block. Maybe you want to get the latest block, and that's just a method. And then I think we had something for is the chain valid? Maybe we want to check if the chain is valid at some point. And well, I guess that's good, right? Genesis block, add block, get latest block is chain valid. So we'll calculate it probably a little. We have that calculated, I think, in the block itself. There you go. So anyhow, now all of these methods are organized in two different structures. If you were to look at this from the very high level and you wanted to collapse some of these things, right? You wanted to collapse your code, you would just have two objects or classes, which is a block and a blockchain. And then if you wanted to inspect deeper into what those looked like, you could, but if you didn't want to, you didn't have to. Because using IntelliSense, and this is often when you get an API and an external library, you don't know what's going on inside. So you have that dot notation. So I have my chain, and if I go dot, it'll give me a list of some of the methods available to me. So we have a property, which is the square for chain. We have the add block method, which we used. You can kind of see it's given us some little information on it. You can add documentation as well. If you were adding documentation, it would show up here, give you a little bit of a highlight of what it means. Create Genesis block, get the latest block, is it valid? And then you see here is just some other things. So the dot notation actually will help us with our signature because we could call it from the outside. And we don't necessarily need to know the complexity inside of the object if it was closed to us. And that's normally how object-oriented programming works, especially if you get a library. You don't know what's under the covers. You just use the interface. But because we're building it out, let's try to build it out a little bit. So we have a blockchain and expanding it back again. It initializes the chain, creates that Genesis block, which is this. We need to add a new block. So if we look at adding a new block, it would take a block, and what it would do is it would push it to the chain. Okay, so maybe we could do the same thing. So we have a new block, and all we want to do is push it to the chain, right? This dot chain and the new block. We haven't really done anything with the hash yet, but we will. So we need to do that, right? To do, just so we remember hashing, previous hash. We need to get the last block in order to figure that out. So we need to go and get the last block in order to do that. So we need to kind of implement this guy right here. So the last block should return this dot. So we have an array. So the chain is an array, and what it should do is return back, because it's zero based, the length. It'll be the length minus 1. So that'll give us, right, if the array has length of 6, minus 1 would give us the 5th position because it starts at 0. So 0, 1, 2, 3. So that's going to give us the last block. When we have the last block, then we could grab its hash. So the last block, if we call it right away, it'll be the Genesis block. So what we could do is on that new block before pushing it, before adding it to the chain, actually what we have to do here is we have to push it, right? This array push, so we're pushing the block on the chain. Before we push it on the chain, we should probably set, sorry, I have someone yelling in the background. We should probably set this hash. And actually we don't have that right now. Oh, we do, sorry. Up here we have, if we look at our class here, we have calculate hash. So let's just return a random number. I think we did random. How did we do that before? So in our previous code, we had calculate hash. We'll just grab this guy for now. This is just going to give us a random number. And we'll just return this guy here so that when we are creating the block in the same way, we can, where am I here? We can actually set the hash. So new block.hash equals new block.calculate hash. So we're going to calculate it before adding. And then we're going to go new block.previous hash is equal to this dot get the last block and his hash. So that's how we're wiring it up. We're creating our own hash, grabbing the last block and grabbing his hash, pushing the block on the chain, and then we should have something ready to go. So if we were to actually try to invoke this guy, let's see if we can invoke this guy at the bottom. So prior to this, we had to initialize, which is way up there, and then we had to get the last block, create the block, and then add it, and then do the same thing. Get the last block, create a new block, and then add it, and then finally output the chain. So a lot of steps there. So now we have a very simple setup. We have the chain, which is defined. And let's just say we want to add to the chain. So we could do chain.addBlock, because addBlock is a method on the chain. And we're going to pass in a new block. So right here, we can define a new block. And the block is position 1, and then whatever the date is, 2022. And what we want to do is give it an amount. I don't know what I did before, why I didn't mention that. We're going to try to put an amount. And then if we wanted to add another block to this, we could add another block, a new class. This guy would be position 2. Maybe we'll change the date a little bit. And this would be an amount of whatever, 50. So if we run this, cross our fingers, okay, we can see here that now we have the Genesis block. We have the two new blocks. They point to each other. Ideally, I didn't calculate the hash for the first one properly, but if you see here, the previous hash was undefined. So there's probably a problem there. It didn't link up to this Genesis block properly. But you can see the next calculation is good because it's pointing back to the last guy. And so on and so forth. So, I mean, this is obviously, we're not checking the integrity of the chain. We're not checking if we're validating the hash or not. So we could continue building this out if we wanted to. But the main thing is that if you contrast it to what this one looked like, it's just a bunch of functions that if you didn't know how to use them, you wouldn't know unless they were descriptive and they had some documentation. And you could very easily mess it up, and you could very easily miss the initialization. And there's a lot of legwork just to get 2 blocks added. Whereas here, it's very, very concise, right? You're creating a new chain, you're adding to the chain these blocks, and then you're outputting the chain. And if I didn't know what the logic was, I could use an interface to interact with this. I'd have some documentation to say this is how you create a chain, and you add the block. That's my API. And then I have something internally creating a block like that. And if you look back at what we did, you know, the class objects certainly help organize our code to 2 objects with their methods, their actions, and properties. And the constructor was super useful in doing some setup, like initializing a chain with the Genesis block, because it only gets called once on the initialization. And of course, every time we're adding a block, all the heavy lifting is done there for us. So we don't have to do it from the outside. it does it internally from the inside. So anyhow, we could build that out. I mean, there's proof of work and mining rewards and all these things you could build into this. But at the very least, that would be why you'd want to use object-oriented programming as opposed to just functional programming. All right, so let me just stop that recording.